to take a look at Chapter 1, Introduction to Data, and we're going to take a look first at case studies. So this is going to be the real-world application of some of the things that we do in statistics and how they relate to nursing. So we're going to look at first treating chronic fatigue syndrome. The objective of this case study was to evaluate the effectiveness of a type of therapy for chronic fatigue syndrome. We had 142 patients in the participant pool, and they were recruited by primary care physicians and consultants. So they were recruited from places that were going to be medical providers. The actual participants would be only 60 of the 142 because only 60 actually participated. And this is something we see a lot in case studies where we're going to identify a group of patients, but not everyone is going to follow through completely with doing the surveys and other pieces. The study design is how the study was conducted. So when we talk about it from a perspective of how was it organized, what was the flow of things, what was introduced to the groups, that's what we're talking about here. The patients were randomly assigned to a treatment group and a control group with 30 patients in each group. Now remember, we had 60 total participating, so we really want to try and keep those groups approximately equal. The treatment group received the therapy we were trying to test, and the control group got just basic relaxation, or what's the equivalent of a placebo. So the control group always gets the placebo or the non-treatment, and they're just not advancing with any of the treatments. And your treatment group gets the thing you're trying to test. So if I look at the table below, I've got the distribution of the patients in my two sample groups with good outcomes at the 6-month follow-up. Note that 7 patients in that 6-month time dropped off of the study. This is also common. Remember, studies are voluntary, and so there are different life circumstances that may cause people to leave the group. And we had 3 leave the treatment group and 4 from the control group. So if we look at the good outcome, we had 19 positive outcomes from the treatment group. We had 5 positive outcomes from the control group. And then we had 8 negatives, or no outcome, no change, and then 21 with no change out of the control group. So if we consider these results and we look at this distribution table, the proportion of people with good outcomes would be 19 over the 27 because there were 27 total people in the treatment group. So we're utilizing this number over here. So that would be roughly 70%, just to give you an idea of what does that number actually calculate to. And the proportion of good outcomes in the control group would be the 5 out of the 26 total in the control group right here. So what we can conclude from that is, what do we think about it showing a real difference? So think about the percentages we just saw, and do we think it makes a, quote, real difference? In the real world, things are often not as black and white as we see in mathematics. For example, if you flip a coin, you're not necessarily going to get heads half the time and tails half the time. Real life changes things. There's other factors. How does this relate to the case study? Because even though you had a treatment group and a control group, there could be other factors that influence those positive outcomes. So we have to really carefully weigh those percentages and consider, are they statistically significant? So the observed difference between the two groups would be the 70 minus 19, 70% minus 19%, which is a total of 51% difference. To me, that's a large enough difference to warrant further investigation with a larger sample. But you have to realize that this could be due to other outlying factors. So we do think it's pretty believable, but there could be some outlying factors, and this is why we have repeat studies. So we want to repeat the study and see if we can replicate the results. And after a couple of times, once we feel confident that we have accurate results and we see a trend in the results, then we can really make a solid conclusion. Are the results of this study generalizable? This is the big piece when we study in medicine, right? We want to know, can this sample group be generalized to the whole population? And so these patients have specific characteristics and they volunteered. The fact that they volunteered right there makes it very hard to generalize this because there wasn't necessarily a clear criteria for the sample, and so the sample may not have characteristics in common with the population. For example, if you're trying to generalize to all females, but maybe you only had 15 females in each group, that would make it difficult to generalize to all females because you didn't have a high group from there. So while you can't immediately generalize results to all patients most of the time, this first study would be encouraging because of that 51% difference. So we would say that this probably works for patients with the narrow set of characteristics that we saw in our sample. And again, we want to try and replicate this, and then we can further study and see, okay, what does this trend look like in multiple studies? How can I study this in people with different characteristics that have more in common with the population and a larger sample size? That's what's going to allow us to really make judgments about the overall results.